Well, hello there. Welcome back to my channel, The Slice of Math. How are you guys doing today? So today we are working on what is labeled as the potato paradox problem, or as I love to call them, the peculiar case of potato paradox. Sounds quite ominous, doesn't it? But let's solve this problem and see, is it really that scary? Okay, so here is our problem statement. A logging company wants to chop down a forest that is 99% sal trees, but the Forest Service's objections. The logging company then suggests it will only cut sal, and after they cut, the forest will still be 98% sal. What part of the forest would be chopped down? And here we have a picture of a beautiful green forest with a couple of elephants just chopping around. So some of you must be wondering that I started the video calling it the peculiar case of potato paradox, but now I'm showing you a picture of a forest and talking about a logging company cutting trees. Well, this is because all the problems in this genre are called as the potato paradox. Now don't ask me why. So I've tried to find out the history of the potato paradox, but I've not found anything yet. So if I ever find out when was the first problem introduced, I will share it with you guys. Okay, so let's go back to the problem now. Let's first understand what the problem is all about. Now we are told that we have a forest which has 99% sal trees and 1% other kind of trees. So this is an approximate picture representation of the problem. Let's just simplify the problem a little bit more. Let us say now that the forest has trees that are 100x in quantity. So that would now make the sal trees to be in the quantity of 99x, and all other trees are 1x in quantity in the forest. So I'm doing this problem in two ways. The first way is using the ratios. So here, instead of saying 100x trees in the forest, let's say there are 100% trees, right? And then we say of which 99% trees are sal and 1% trees are other variety. So this is a 1:99 ratio. But the logging company have stated that they want to cut the sal trees in such a way that the trees go from 99% sal trees in the forest to 98% sal trees. So let's see how we represent this in the ratio format. So here we have 100% trees in the forest, of which now after the logging company have cut, we have 98% sal trees. But then how much percentage of other trees are left? To get 100%, it has to be 2% other trees, right? Thereby making the ratio as 2:98. Now let's focus on the ratio that we have achieved. We know the ratio is now 2:98, or it is 1:49. So let's do a reverse calculation. 1:49 means we have 1x other trees, 49x sal trees. When you add them up, you have got 50x trees. So the trees went from 100x to a 50x. So this was an explanation using the ratios. As I have mentioned before, I have another explanation for you. Let's go through that. So before cutting, number of trees in the forest be 100x, which is 99x sal trees and 1x other kind of trees. After cutting, number of trees in the forest be 100y, which is 98y sal trees, and 2y we have other trees now. But 2y is actually x because the quantity of the other trees has not grown. That has remained the same. So we get y, which is equal to now x by 2, half of x. So let's just replace y in this highlighted number 100y, and we would then get 50x, meaning the quantity of the forest went from 100x to a 50x. So if the Forest Service agreed to this number jugglery that the logging company have done, then the trees would actually get cut down by half. So how is the problem? I hope you guys had fun. I am always eager to get a feedback from my audience. So please drop me a message. If you like my video, please click the like button, and I would really appreciate if you would subscribe to my channel. Anybody having interesting problems that they want me to make a video of, I would love to have a discussion about that. So drop me a message regarding that too. I'll be back again soon. Take care, stay safe, and ciao.